First, we will be going over properties of gases, Boyle's law, and then Charles' law. So, how are gases different from solids and liquids? Gases have no definite shape or volume. They can expand to completely fill the container and take the shape of their container. Gas particles are spaced far apart relative to one another. The particles are moving with rapid, random motion. Gases are less dense because they have loosely bounded particles and large intermolecular spaces. Lastly, gases are easy to compress because most of the volume occupied by a gas is empty space. In conclusion, gas does not have a definite shape or volume. Their particles are far apart, have little attraction to each other, and move at higher speeds, taking the shape and volume of their container. They are also less dense and easy to compress. In the kinetic molecular theory, it states that gas particles are in constant motion and exhibit perfectly elastic collisions. Kinetic molecular theory can be used to explain both Charles and Boyle's laws. The average kinetic energy of a collection of gas particles is directly proportional to absolute temperatures only. Here, I will provide 5 points to summarize the kinetic molecular theory. 1. A gas consists of small particles that move randomly with high velocity. 2. They have essentially no attractive forces. 3. They have very small volumes. 4. They bounce around constantly in straight lines. And 5. They have kinetic energies that increase with an increase in temperature too. Despite wide differences in chemical properties, all gases more or less obey the same set of physical properties. The 4 quantitative or physical properties of gases are interrelated. The first property is pressure. It is known by the symbol P. Pressure is the forces exerted by gas particles, ATM, which is short for atmosphere, mmHg, which is short for millimeters of mercury, torr, which is a unit of pressure based on an absolute scale, which was named after Evangelista Torricelli, psi, which is pound per square inch. The second property is temperature. It is seen as the symbol T. Temperature is proportional to kinetic energy. They use K, which is short for kelvins. The third property is volume. It is seen as the symbol V. Volume is the size of the container. The units associated with volume are milliliters and liters. The fourth property is moles. It is seen as the symbol N. Moles is the amount of gas particles. We can use moles, but it can also be seen as grams. Here is a question for you. Explain this phenomenon. When you take a potato chip bag up the mountains, the bag puffs up because A. At higher elevation, molecules move faster. B. At higher elevation, the pressure inside the bag is greater than the pressure outside. C. There are more air molecules in the bag than before. The answer would be B. At higher elevation, the pressure inside the bag is greater than the pressure outside. This is because the amount of air in a bag of chips is fixed. If the package was sealed at a lower elevation and carried to a higher elevation, the air inside of the bag will swell against the reduced atmospheric pressure. Now we will be going over Boyle's law. Boyle's law is when a change in one property causes a change in another property. The volume is inversely related to the pressure in this case. So what does the relationship between volume and pressure mean? If the relationship is inversely proportional, a decrease in the volume would increase the pressure. If the relationship is directly proportional, an increase in temperature would also have an increase in the pressure. Boyle's law holds true only if the number of molecules and the temperature are both constant. It is also used to predict the result of introducing a change in volume and pressure only, and only to the initial state of a fixed quantity of gas. The relationship for Boyle's law can be expressed as P1V1 equals P2V2, where P1 and V1 are initial pressure and volume values, and P2 and V2 are the values of the pressure and volume of the gas after change. Here is another question. When your lungs expand and if the temperature and amount of gas in your lungs is constant, how has pressure changed? A. Pressure is decreased. B. Pressure is increased. C. Pressure is also constant. The answer would be A. Pressure is decreased. Here is an example of Boyle's law. Freon 12 CCl2F2 was used in refrigeration systems. What is the new volume in liters of an 8-liter sample of Freon gas initially at 550 milliliters of mercury after its pressure is changed to 2,200 millimeters of mercury at constant temperature and moles? So in this example, we know that the initial pressure is 550 milliliters of mercury, and the final pressure is 2,200 milliliters of mercury. The V1 initial is 8 liters, but we don't know V2. We know our given values and what we need, so we use Boyle's law, P1V1 equals P2V2. Since we are looking for V2, we need to divide both sides by P2. The P2 on the right side cancels out, leaving you with just V2. To make it more simple, we will rewrite the equation. Next, we plug in all the given values. The milliliters of mercury cancels out, leaving you with just liters. Lastly, you plug in all of the numbers into a calculator, and this gives you the answer V2 equals 2.0 liters. Finally, we will be going over Charles' law. It is when volume is directly related to temperature. When gases are heated, they spread out. The temperature increases, so does the volume. This law applies to ideal gases held at constant pressure, where only the volume and temperature are allowed to change. Charles' law is expressed as V1 divided by T1 equals V2 divided by T2, or T1 divided by V1, or T2 divided by V2, where V1 is the initial volume, T1 is the initial absolute temperature, V2 is the final volume, and T2 is the final absolute temperature. The temperatures are absolute temperatures, meaning they are measured in only kelvins. Here is an example of Charles' law. A balloon has a volume of 785 milliliters at 21 degrees Celsius. If the temperature drops to 0 degrees Celsius, what is the new volume in milliliters of the balloon at constant pressure and moles? So we know the T1 is 21 degrees Celsius, the T2 is 0 degrees Celsius, V1 is 785 milliliters, and we don't know the V2. Since the temperature is 21 degrees Celsius, you would have to convert it to Kelvin. So you would add 273, and that would give you the answer 294 K for T1. And you do the same thing with T2 too. So that would be 0 plus 273, which gives you T2 equals 273 kelvins. So we would start off with Charles' law formula, which is V1 divided by T1 equals V2 divided by T2. And in order to find V2, we would have to multiply both sides by T2. The T2 on the right side cancels out, leaving you with only V2. To make it easier to see, you can rewrite the formula. Next, you plug in all the values in the equation, and the K's would cancel out, leaving you with just milliliters. Finally, after plugging in all of this into a calculator, it will give you the answer V2 equals 730 milliliters.